Now that we've gone over what our service models look like in our stack layers, let's go on and talk about what public, private, and hybrid cloud means. Now, I know this may be review for a lot of folks, so let's just go back and make sure that everybody has a good understanding, and if you need to, you can maybe bump ahead a little bit. Public clouds, as we've become well aware of because there's a lot of options out there today, are built around a service provider cloud. We have a firewall that's in between us and the service provider cloud, generally raw internet accessible, and then we, down below, as a consumer of the service, we make requests into that service provider cloud through our network out to that publicly available environment. It's really just that simple. All our resources are rendered in the public cloud, and that's how we access them. In a private cloud environment, we have the same cloud concepts, except this is going to be an entirely on-premises cloud environment. The abstraction layers are still there. The difference is that the hardware is on the other side of the firewall. The consumer is now inside on the same network, or at least in the same general region as the on-premises cloud. Now we consume services from our on-premises environment, and they're living inside the firewall, inside that same environment where the on-premises cloud is. It's not that they can't be presented externally through DMZs and other external firewall rules, but the resources themselves are all inside our on-premises network. When we have hybrid cloud environments, this is exactly what it sounds like. It's a hybrid of those two models of public and private cloud. We have our service provider cloud, which could be any cloud that we talk about. We have an on-premises cloud, which has matching layers and matching services. We create a secure VPN tunnel between the service provider cloud and our on-premises cloud. And this creates what we now know as our secure hybrid cloud. Our consumer makes requests into the secure hybrid cloud, and the services are rendered where we require them. Perhaps a service provider server is all that we need. Or perhaps we want to have one in our on-premises environment. Perhaps we have one that's in our service provider environment and we need to move it into our on-premises environment. That's the great thing about the hybrid cloud model, is that you can move your workloads as needed. It's very important because modern workloads are now changing where we need to be elastic not just on premises, but perhaps we can have that flexibility and elasticity of using service provider public clouds, and yet we have the security and safety of our on-premises environment, and we keep those control layers inside our own environment. Next, we're going to talk about APIs and the software abstraction layer. When we talk about an API, it's an application programming interface. Now, when we use APIs, the advantage to this is it has a few important criteria. We don't need to be using traditional binary applications to use it, so we can consume that API using any number of methods. It's a completely open environment, regardless of the platform now, because the API itself is agnostic to what it's being consumed by. So there's no strict language requirements. We could run Python, Ruby, C++, Erlang, or any of a variety of different languages because we only have to consume the API in the way that it's available to us. You're going to hear the word REST a lot. REST means representational state transfer. I know that's a kind of a crazy word, but this is all you need to remember. It's based on HTTP verbs. And if you don't already know what that means, it's something we're going to refer to as the CRUD model. That's a really easy one to remember. If you can't remember CRUD, well, just write that one down. It's kind of a fun one anyways. What it means is C, create, R, read, U, update, D, delete. All you have to remember, C, R, U, D. Using these verbs, we can access the API and send commands to it in order to create resources, to read existing resources, to update existing resources, and to delete resources. So now that we know what an API is, and using RESTful, again, that's another term we talk about, is RESTful, meaning that it's a RESTful service. RESTful methods are happening at different layers. And this is where we enter into northbound and southbound. For some folks, these are really different concepts, and as more and more abstraction happens, this is what we're going to see. APIs in most environments now are exposed in two different directions. A service consumer, which is generally us, the consumer of the environment, we use what's called a northbound API in order to make a request into that abstracted layer. And then down underneath it, the southbound API goes further into the actual hardware itself. This allows for flexibility and programmatic control of hardware and software. And by programmatic, we mean, through traditional web programs or even executable and binary programs or simple scripts. We can use those RESTful methods in order to access these APIs for both hardware and software layers. And the win for everybody is there's much less rigidity when we have API layers. We used to be bound by very strict version requirements and all these environmental requirements in order to run applications as binaries. And now we've tried to remove that by making everything API based. You'll generally hear people ask about, do you expose a RESTful API? And this is what it's all about. So layering, when we look at it in the API world and how we've just described it, we have our very bottom layer. Well, we had some storage down there. In fact, we have a pool of storage. And that's exactly what we create. We've created an abstracted pool of storage resources. Then we have a number of compute resources, which we call a pool of compute resources. Our compute resources can use southbound APIs into our storage layers to consume storage services. Our cloud environment is now how we would consume compute services. So the consumer of the environment, there's a lot of consumption in there, so you'll pardon all those layers, but this is exactly how it looks like. Now our consumer makes the request into our cloud environment, and through those layers of abstraction and southbound and northbound APIs, they're now able to consume compute resources and storage resources, all with simple RESTful commands. Or in fact, it may just be a simple click of a button in a service catalog.